This is our lesson 20, part 1 in our Sapphire Kingdom Gemology YouTube channel. In this video, we are talking about diamonds. From here, we are starting diamonds. Then after that, this is lesson 20, then 21 also diamond. Then after that, lesson 69 is also diamond. That is the last part. In 69th lesson, we are grading. We are doing color grading and clarity grading, everything regarding diamond. So you better follow up from this to up to 69 also. Now this is 20. Look at the first picture here. It is big uncut 1109 carats 2017. This is sold. This was sold in 2017 for $3 million. It is in 2015 it founds. Look at this. See the difference between the egg and the diamond. The little bit same size. This diamond sold $13.8 million. So this is some example. Now, if you forget to subscribe, please subscribe and press the bell icon. I am moving to the lesson. Now look at how diamonds are creating in this earth. There are 4 ways. First one, deep source eruption. Look at this. Deep source eruption. Volcanoes are starting eruption. Then it creates diamonds. These are the yellow dots are the diamonds. So in this area, diamonds are creating with the high temperature and high pressure. Then it comes to the forward through a deep source eruption. This is continental plate. This is ocean. This is oceanic plates. So number 1 method is deep source eruption, volcanic eruption. Number 2 is oceanic plate moves always, then oceanic plate moving, the continental plate also here, then both are meeting together here with a big power. Then it creates diamonds. That is number 2. Subduction zone. This is the zone. Then this is number 2. Upper mantle and the diamonds are here also. All the diamonds created in upper mantle comes to the deep source eruption comes to the upper level. When the volcanic exploration, it is the first method. Then the second method, the oceanic plate and the continental plate moves together and there may be another source. Number 2. Number 3 is asteroids coming from outer side of the solar system. Out of the earth, moving asteroids are there. So they are sometimes come to the continental plate and eruption is happening here. Then it creates diamonds here. It is number 3. Number 4, meteorite fall. That is meteorite fall. It's here. You can see at the night, you can see this falling like stars coming to the earth. So it creates diamonds. Now you can remember there are 4 methods. One is deep source eruption, volcanic eruption. It brings the diamonds from bottom to top. Then the next one is oceanic plate and continental plate. When the plates move in together, there is a big power here. So it creates diamond. It is number 2. Asteroids come into the earth. Then very big exploration is here. So it creates, that is the 3rd method. 4th one is meteorite fall. These are the main 4 methods that diamonds creating. Look at the first one. Deep eruption, deep source eruption, continental plate, upper mantle, diamond stability zone inside the earth is here. See, diamonds are creating there, already created. So those are coming through the volcano. And the oceanic plate, number 2. And the oceanic plate and the continental plate is moving together. Then it happens here. Subduction zone creates the diamond. Diamonds from ocean sediments. Here, diamonds from deep source eruption. Most commercial diamond deposits are thought to have formed when the deep source volcanic eruption delivered diamonds to the surface. This is number 1. This is number 2. Now we are moving to number 3. Asteroid impact. This is continental plate, upper mantle. Diamonds have been found in and around the craters of many asteroid impact sites. You know, asteroid impact sites, there are a lot of, we can see inside the earth, around the craters of many asteroid impact sites. An excellent example is Poppyguy crater. Poppyguy crater, we can discuss later. It is number 3. Number 4 is meteorite fall, extraterrestrial diamonds. This is called extraterrestrial diamonds. Diamonds have been discovered in some meteorites. So there are 4 sources. Now look at this. This is the Soviet scientist had in the 1970s uncovered the 100-kilometer, that means 60-mile Poppyguy crater left by a huge asteroid in Siberia 35 million years ago. This pit creates with the asteroid falling. So in Soviet Russia, they found the diamonds from this pit. It is most famous Poppyguy crater. See the diameter, 100 kilometers. That means 60 miles diameter. It is very big one. 35 million years ago. Diamonds were formed over 3 billion years ago. See, 3 billion, not million. Diamonds were formed over 3 billion years ago deep within the Earth's crust. Under conditions of intense heat and pressure that cause carbon atoms to crystallize, forming diamonds. Diamonds are found at a depth of approximately 150 to 200 kilometers below the surface of the Earth. But gems are more closer to the Earth crust. But the diamonds are very big area covered, 150 to 200 kilometers below the surface of the Earth. Gems are found near the surface of the Earth. This is the one difference. Then, look at the Rutherford crater, 300 kilometers wide. Poppyguy crater, 90 kilometers wide. These are the places. It is the world's largest known impact structure. About 2 billion years ago, an asteroid measuring at least 10 kilometers across hurtled toward Earth. It creates this Rutherford crater. The wide, 300 kilometers wide, you can imagine it. Then, Poppyguy crater, 90 kilometers wide, we discussed earlier. They only examined, in Soviet Russia, they examined only 0.3% of the entire territory of the crater and had already established 147 billion carats. 147, not million, billion carats worth of diamonds. It uses for industrial purpose. So not the jewelry purpose. So we are talking about many trillion carats still there. Many trillion carats are still there, not found. Soviet scientists had in the 1970s uncovered the 100-kilometer apical crater left by a huge asteroid in Siberia 35 million years ago. That picture is in the most left side. This is the place. GPS location is here. Then, what is this? Another diamond. Lonsdaleite. Small amounts of lonsdaleite are reported to be present in the diamond-bearing rocks of the Popigai crater. Lonsdaleite is a rare carbon mineral with a hexagonal crystal structure. But the diamond is tetragonal. This diamond is hexagonal crystal that has been associated with diamonds in meteorites and at impact structure. So you can see in Facebook, I saw a lot of landslides, but some are synthetic, man-made. Like diamond, it is a mineral that forms under conditions of very high temperature and pressure. It is often referred to as hexagonal diamond. Another name for this is hexagonal diamond, lonsdaleite or hexagonal diamond. Both are same. Now, we can see here, due to the immense pressure that is present in this part of the earth, as well as the extreme temperature inside the earth, a diamond gradually begins to form. The entire process takes between 1 billion and 3.3 billion years. Entire processing time to form a diamond is 1 billion to 3.3 billion years, which is approximately 25% to 75% of our Earth's age. See the age of the Earth and the age to be created. 1 billion up to 3.3 billion years need to form a diamond inside the Earth. Now look at this picture. It shows this is the core, volcanic core. When the volcanic process happens, it brings lava to the surface of the Earth like this. And this little lava mountain explodes. Then this is called volcanic eruption. Build in a cone. It builds a cone. Then after that, erosion of the volcanic rock, rain and the temperature difference and the air is there. So climate changes cool the volcanic eruption, and suddenly it cools inside the cone. Then it, after several years, it leveling of the cone. Cone is leveled now. This cone is leveled. Inside the cone is here. Then exploitation of the pipe. This is called pipe. Exploitation of the pipe matrix above ground and along tunnels. This is the tunnel, and these are the levels of 3 tunnels. Using these tunnels, we can take these cooled areas diamond into the earth crust. It is very big project. So we should understand this. Now look at this. How diamonds form underground. It is mentioned here. This is the earth crust. This is continental plate. This is mantle. Inside the mantle, it is lava, heated lava here. Between 1 billion to 3.3 billion years, it forms diamonds. So the diamond formation happens here. Then with the volcanic lava, diamonds are coming to the Earth's surface. This is the crater. This is the crater. Then this pipe is called kimberlite. Kimberlite pipe means this. For example, this is kimberlite pipe. We have to make a hole and go through these holes and collect the diamonds and bring it to the earth's surface. So this pipe is called kimberlite pipe. So this is kimberlite pipe. Now you can understand this picture. Then a typical diamond mine. This is a diamond mine. This is the factory. This is the mine shaft. So look at the height. Then the elevators are moving from top to bottom. And drainage pipe is here. Elevators are moving from here to here. Then 1,520 feet, that means 463 meters below, there is another hole. It's moving there and collecting the cooled diamonds from this tunnel. This is called kimberlite pipe. Old open pit. This is the part of open pit. All the diamonds here, they have collected. People have collected, but in this area, no. Then this area is debris from old mine. After, below that, there are a lot of diamonds here. Then 561 kilometers depth, another hole. 658 meters in depth, another hole. Can collect all the diamonds here. It is big project. So inside the kimberlite pipe, diamonds are cooled and there. So diamond mine is very big project. Okay. Now look at this. Diamond is a giant covalent substance in which each carbon atom is joined to 4 other carbon atoms by strong covalent bonds. Covalent bonds are the name of the bonds. Each carbon atom is connected to, look at this structure. Each carbon atom is connected to another 4. Look at this. Another 4 is connected together. Then that bond is called covalent bond. The carbon atoms from a regular tetrahedral network structure. This network structure is called tetrahedron. It is this. This is rough diamond. 4 sides. Pyramids. Double pyramids with 4 sides together. So that is called tetrahedral. So this tetrahedral creates with 4 carbon atoms. There are no free electrons. All the electrons around the carbon atoms are satisfied with each other. So this is called diamond. Look at the tetrahedral connection. Each carbon atom connects to another 3. It creates this shape. It is called tetrahedral. Now look at the graphite. Graphite also pure carbon. Diamond also pure carbon. The difference is what? Can you guess the difference? Inside the graphite, each carbon atom is joined to 3 other carbon atoms by covalent bonds, same kind of bonds. But inside graphite, it is connected only to 3 carbon atoms. In diamond, each carbon atom connected to 4 carbon atoms. Then it creates tetrahedral shape, lattice. But the graphite connected only for 3 carbon atoms with covalent bonds. The carbon atoms from a hexagonal layer network structure. The layers are, the graphites are, creates hexagonal layered layers. All the layers are together, one over the other layer, one over the other layer. It creates a graphite, but it is completely pure carbon. But the diamond also completely pure carbon. See the difference. between the graphite and the diamond. Okay. Now here, diamonds are made of carbon, so they form as carbon atoms under a high temperature and pressure. They bond together to start growing crystals. It is this crystal. That's why a diamond is such a hard material, because you have each carbon atom participating in 4 of these very strong covalent bonds that form between carbon atoms. But remember, inside the diamond, there are 4 carbon atoms joined together with a covalent bond. But in graphite, only 3 carbon atoms are joined with covalent bonds in hexagonal way. This is tetrahedral. This is the difference between diamond and the graphite. Here you can see the diamond crystals. Octahedral. Octa means 8. Hedral. So look at here. One, there are four sides with the cone, double cone. Then altogether 8 sides are there. So octa means 8. Hedral. Octahedral means that shape. Look at the crystals, diamond crystals. Octahedral rough diamond lot is here. One face of an uncut octahedral diamond showing. Look at the shape. Look at the shape. Octahedral, there are 8. Out of that octahedral diamond, uncut diamond, this is one face. This is one face. If you see carefully, you can see trigons of positive and negative relief formed by natural chemical etching. It is etching. You can find the triangle-shaped marks on the top of the skin of one face. It is special thing. It is special thing. Somebody make a comment with me, ask a question regarding this. Then I told him, look at the lessons. Then he will find. Now you can see under this. What is this symbol? Now, how to cut diamonds? How diamonds work? Cleaving. Now, look at this diamond. This is the rough diamond. Look at the picture with me. This is the rough diamond. No shape. So, rough diamond is placed in quick drying cement. Quick drying cement is there. It is placed here to break and cleave. Fix with the diamond. Then, third, a sharp groove is then carved into the diamond. We are solving it. With laser beam, we can cut it with laser beam. Number 4, it is this. Let's look at the number 4. A small steel blade is placed in the groove and a sharp blow to the blade splits the stone. Then we can break it into 2. 5. Now it is 2. The rough diamond is then removed from the cement. This is the way we are cutting into 2. Now look at the rough diamond here. Diamond is single refractive gemstone, not double refractive. So we can take when we are cutting the diamond, we can take the table facet to any direction. Look at the main stone. Table is this. This is the side. If it is a sapphire, we have to think about the z-axis and the pleochroism. We need to take the surface into pleochroism side only. But it is double refractive sapphire. If it is single refractive, we can take the face to any other side. So the big one's face is here, and the little one, another little one, the same face is there. But look at this part. Another gem is created in the faces this side. Here, the face is this side. Here, that face is in this side. Look at this stone. It is face to this side. How many stones we can cut from this diamond? 1, 2, 3, 4, 5, 6. Then the biggest one is 2 carat diamond, biggest one. The price $27,120. So this part creates 0.33 carat poor make, another poor make. This is the excellent make, 0.45 carat. That means 45 points. 15 points one poor make. This also poor make, but 65 points carat, 65 points. And this one 18 point. Then the carat price is here. The price is here, not the carat price. Whole stone price is here. So whole part of the diamond we can cut and polish. But in sapphires, we can cut only for the pleochroism side. Table must be there. We can cut this one if it is a sapphire, and this one also. We cannot cut this one, this one, this one, or this one, because it is not focused to the pleochroism side. So if it is a sapphire, we can cut only 2 stones. But if it is a diamond, we are not wasting the diamond. We are cutting even small piece also. Now we are moving to the next. Now look at this table. Extraordinary appearance and brightness due to high refractive index. Elementine luster. Elementine luster is the luster of the diamond. Crystal structure is cubic crystal. Composition is pure carbon. Luster is elementine. Hardness is 10. Biofragrance is none. Ri is 2.42. All the gems are below 1.8. But the Ri of this, it is more than 2. 2.42 diamond because of the hardness. Specific gravity is this, 3.52. Crystal structure, you can compare these 2 tables with sapphire and diamond. Sapphire is trigonal, but the crystal structure of the diamond is cubic. Composition is pure carbon. Composition of the sapphire is aluminum oxide. Luster is elementine in diamond. Luster in sapphire is vitreous, like glass. Hardness 10, sapphire hardness 9. Biofragrance none, but biofragrance there 0.008 because it is double refractive. This is single refractive. That's why none. Ri is 2.42. See the Ri 1.76 up to 77. Big difference. Specific gravity is 3.52 in carbon, but the sapphire is more higher, 4.0. Now you could understand the differences between sapphire cutting and diamond cutting, and the appearance and the other physical and chemical properties. Then join us and learn and enrich your future. Please subscribe and press the bell icon. In the next session, we are continuing lesson 21. It is diamond part 2, and the 69 also the diamond. Lesson number 69 also. So you better follow up the lesson order. Don't miss the lesson order. Follow up the order. Then we are meeting on next lesson.